In this talk, my colleague Ivo and me will be talking about building the API layers on top of mainframe and trying to provide a different perspective on this topic of modernization and very popular, like trendy stuff now regarding this famous like breaking the monolith. So first thing, a little disclaimer. I'm usually the guy that gets brought in on the other side, so outside of mainframe, and they tell me, you know, our strategy is to kill the mainframe and you're the guy who's going to kill it. And sorry? Yeah.
Right now,
but
killing it.
The reason why I'm here is because I wouldn't say that I failed, but I realized that this is not something that I should be doing. The goal is to find a proper place for a mainframe inside the IT system, IT organization. So a little bit like content. So first, what I want to talk about is about the challenges with monoliths in particular. So usually the software that is built on the mainframe is a monolith. I want to talk a little bit about the challenges that are there and why there are challenges with monoliths. Then I want to talk a little bit about the reasons, how to break it, and the last part is, you know, the solution regarding the API layers, and Ivo will tell us a little bit about the tools and stuff, how we did it. So first things, challenges. So in the mainframe, you know, and in the monoliths, transactional consistency is everything. So ACID is the king, you know, everything needs to be transactional. You have to have a begin transaction, you either successfully commit or you either roll back everything. But it turns out that real world is not really like transactional, you know. When you take money out of an ATM machine, you know, stuff can go wrong. Even you know, in a face-to-face communication, if you're handing money to someone, you know, the money can drop on the floor and you need to handle that. So it's like real world is much more difficult than like ACID. And we built a lot of abstractions around it, but it's easier for us to pretend that the world is like transactional. So either some action is completely successful or either some action is failed, and we can roll back to the last known safe state that we were in, and we can either retry or do something else. And then we pretend that it is like this, but since it's not, we need to build abstractions to keep ourselves in the delusion. So we build ourselves like these database systems, transaction coordinators, you know, we bring in support for distributed transactions and everything, and this works great when we are in a monolith. So all of our data is in the one place, all of our code base is in one place. So when we need to develop some new functionality, we can call in wherever we want, we can read whatever data we want, we can update whatever data we want, and everything is great. But there are problems, you know. We delude ourselves, we build monoliths, so all or nothing. This is easy to reason about, and this is simple, you know. Either I take the money out of the ATM, either I pay some bill, either I order some insurance, either I'm successful or I'm not. And this is simple and easy to reason about. But there are problems, you know. Illusions are starting to break apart. First thing, why? Because physics. Simply, we cannot put more transistors on a chip. You know, we have come like to some kind of a plateau, and even if we have like this existing softwares and we want to use them more and more and more, we cannot throw more hardware at them, you know. In a single process. Okay, we can always like multiply, get more cores and stuff like that, but then we are really not really talking about like, we are opening a whole other can of worms here. And because of this reason, and for the reasons that amount of data in the world is growing, amount of business processes that we need to support in order to support this digital modern world where, I don't know, when we started building these systems a long time ago, there were just a few like core business processes that were like digitalized, and most of the stuff was done on paper. And over time, as the society gets more and more digitalized, we need to support more and more business processes inside our application systems. And that inevitably, however do you want to put it, drives costs up. And we need to do something about it. And the reason and the thing that we can do is we can break this monolith into smaller pieces so that we can keep the illusion going, but just on a smaller scale. But this is a problem because you solve it on one side, but you introduce problems on the other side. And then it's like this constant dance of tangle between compromises. So either we are ACID or we are not ACID, either we are monolith, either we are microservices. So we need to find the right balance how to do it. And in all of that, what we are doing, we need to we respect the fact that there are these big old heritage systems built on top of mainframes that are generating a lot of money for companies, that companies, organizations have invested a lot of money, a lot of manpower, a lot of man days to code up and codify and implement business procedures inside those languages. And it is simply, in my opinion, not feasible that, we'll say, okay, let's throw everything out, let's throw 30, 40, 50 years of experience out the door, and here is this new shiny generation, and we will build everything anew because we know how you don't know how to do it, we will do it better. It doesn't work like that, and it's, if I may say, plainly stupid. Why would you want to throw out something that is working, that is generating money? This doesn't make sense. But we need to do something, and we need to bring mainframe into modern world. So basically we need to put it and accept the fact that the mainframe will be a part of our modern IT infrastructure, but since it's a monolith, and we need to open it up to a world. And how do we open it up? We build APIs on top of it, we break it. And now when we need to break the monolith, there are some challenges. The first question is, okay, where to break? How do you break it so that it makes sense? This also inevitably have an impact on the business process, because now you had like this illusion that everything is transactional, everything is either it's completely, successful, or it is not, it failed, so it's rolled back. Now, when we break it, this illusion has shattered, and this has an impact on the business process. So we need to think about it. What is happening with the business process that are now has to be supported from something that is broken up? And then the last question, in terms of like organization and stuff, how do you manage now this multitude of components that you have? So now we had like this one big component, when we deployed it all at once. When we tested it all at once. There were challenges with that, but it was like simple. We knew how to do it. We were doing it for a long time. So we kind of ironed out all the child diseases and stuff like that. And we had like processes that kind of mostly worked. And now we are throwing all of that apart. And now we need to ask ourselves, okay, how do now we manage this new world where there are multiple components in there? And let me talk a little bit about some answers to those challenges. So first, where to break? The usual and only correct answer is there is no silver bullet, and it depends. It always depends. But there are some strategies that we can use to try to figure out. Sorry, is there a comment? Yeah,
That's right, it's true.
Yeah. Even in that answer, there are like some techniques and approaches that one can use and apply to try to figure out the answer to that question. And there are like those I like to call them like natural seams between existing components, because even though we say that the software on the mainframe is a monolith, it's not really true. There are some components there. There are like some interfaces and stuff like that, and there are some business processes, cutoffs inside the business process. So there are some places like these seams where the ties between the components are not so high, like in some others. So for example, I mean, if we compare it to like a model of an atom, if you try to break apart a core, you get a really big explosion. But if you try to like take the one electron for the outer shell, you can do it. It works. So we need to look for where those natural seams are, and usually the first place where I look when I have to search for it are transaction boundaries and asynchronous operations. So if something is asynchronous, if it is moved in time, so that's usually a good place to start and see, okay, whether or not we can break this thing apart and see what we can do there. And of course, we always need to think about the business process that we are breaking up with this, because different business processes require different levels of consistency. If you have a business process that you're supporting that requires really strong transactional consistency, there is no way to break it up without huge amount of pain. And one should have a really good reason to go in and break it. So the second challenge is how to break it. And this one is more like on a technical side of things, but I would say it boils down to two primary topics. First is, where is the data? Because in the mainframe we are so used to having all the data locally available on the machine. Data is either in the in some form of database or wherever where it's stored. And we are are used to write software in such a way that data is there, it's near, it's us. The platform is taking care of all the partitioning and where it is and how it works and stuff like that. But if we are going to break it and introduce some new modern components that need to use that data, there are two approaches. Either we can go and talk to the mainframe and ask him, okay, what is this data here? Or either we can move that data out of the mainframe. But then it boils down to the question how to move it out. There are two approaches. Either is we can partition it into multiple monoliths, and the other is to replicate it. And why replicate it? Because we want to keep the source of truth on the mainframe. Because if we start splitting these little things apart, we have to respect the fact that there are still some components that are left on the mainframe and will be there for the foreseeable future, preferably forever, because this only makes sense. And we need to think about how do we manage data and how do we manage consistency in a world where there is no longer ACID. And after we figure out how do we want to approach this data problem, there is a second thing, is how do we now update this data? How do we read this data? And this is the topic of introduction of new transaction boundaries and actually breaking the system across time. So what this means? This means that if you do a write transaction that is performing a write into a database on the mainframe, you have to respect the fact that if you're doing a read from some data store that has replicated data from the mainframe, it takes time for that data to be replicated. Maybe this time is usually very short, but we have to respect the fact that networks are unreliable, things can go wrong, something goes wrong, and we need to respect the fact that this will result in a fact that maybe what somebody sees in the replicated data and what somebody sees on the mainframe are not the same things. And business processes need to adapt to that and they need to include that into their specifications. There is no other way around it. And now when we talk about, okay, how do we now technically do this? How do we replicate data? How do we introduce new transaction boundaries? Well, actually the answer is pretty straightforward. We introduce APIs. We introduce either synchronous APIs or asynchronous APIs. And when I'm talking about APIs here, I do not think only merely about, REST APIs, HTTP, GET, host port / product / get / one. I'm talking about all the interfaces where you can speak to a mainframe. So it can be like Kix transaction gateway. It can be really a REST endpoint. It can be a JMS queue. It can be like temporary table inside a DB2 where you are like writing some data in and then you have some batch job on the mainframe. So all of those points are APIs. And we need to think about different technical implementations and technical capabilities that we get with each and every type of an API. So, for example, if we need to read something, yeah, HTTP, it's great. But if we want to write something and we want to write it consistently, maybe HTTP is not the best thing to do. Maybe we should do something different. Maybe write to some queue during through a distributed transaction. Or if we really want to use HTTP, then we need to respect the fact that we need to adopt the code on the mainframe so that it's independent. Usually it's not, because nobody in the ACID world, nobody thought about independency, because we are ACID. So that's the impact on the business process. And we need to respect the fact that not all business processes are created equal. When we have this illusion and abstraction that everything is ACID, it's easy to think about it, and every business process that you support on the mainframe, you support it with that transactional consistency in mind. You do not think about it whether or not do you really need it, or you don't need it. You just do it because it's there. It's easy to do it. But when we are breaking things up, we need to respect the fact and take into consideration that not all business processes are created equal, and we need to retain ACID properties for the critical ones. And this inevitably means that with the introduction of new transactional boundaries, some business process will have to adapt. You will have to talk, we have to talk to business owners of some functionality, some web portal or something, and state the fact, okay, you have this new requirement. In order to implement this new requirement, okay, we need to go to the cloud because something. This requires that we replicate some data from here to there. The limitations of these technologies are this, and this. And if we want to support that, what we need to do, you need to change a little bit how you define this business process. It's still the same business process, but it's maybe defined in different terms. One good example that I had recently was at one bank that had a mobile banking app, which connected every time you wanted to see the list of transactions on your account. It shot a request straight to the mainframe database, to read the list of your transactions. And it was really heavy, especially in Croatia on the 15th in the month when there are payrolls, everybody are checking on their mobile phone, is the pay here, how much did they get, and it was come crashing down with these reads to the mainframe. And what I said to the customer is, why don't we replicate this data out? And you say to your customers, okay, we are serving now this data from this outside database that is just a read database for this functionality. We will relieve the burden from the mainframe so it can do what it does best in terms of writes and stuff like that. But we need to respect the fact that maybe when you do a transaction, it will take 5 seconds to be shown on the mobile interface. And then the first initial reaction was, no, we cannot do that. If I hit pay and I go there, I will need to see the transaction there immediately. And I said, why? Let's just, put a little change on the UI and say, the last timestamp of this data is like from 5 seconds ago. And nobody cares. And we have adopted a business process, we have broken a monolith, we have enabled our existing systems to breathe in a little bit. They can now focus and do what they need to do, and that's like process transactions, and not like serve some mobile application. Not that it's anything wrong with serving mobile applications, but there is a time and a place for every use case. And then the last challenge that we have is this notion of how do we manage multiple components. And we need to respect the fact, and that's just plain and simple. It has been a lot of talk in this last day and today regarding this bringing the mainframe into an existing landscape with this like tools like Git, Jenkins, SonarQube and stuff. So it basically, for me, it boils down to the thing that we need to use same DevOps procedures, same CI/CD procedures, same versioning schemes, so that we know, if we have a version of the mobile application X, we can correlate it to the version of, Kix transactions that we deployed on the Z. We need to have the same release procedure, so there is no like ivory tower for anybody. When we release all together. We are in it together. We need to monitor the systems, and we need to use this infrastructure as code as much as possible, so that we can, when we need to change something, there is as little as possible manual work anywhere inside the system. So hopefully when you get to a state that you are pushing something to a production, it's really just a one-click. There is, if you have in your release procedure a step, somebody should log in somewhere and do something, work hard to figure out how to do it automatically. Because in the long run, it will pay out. And with that, I will conclude, and I'll hand over to my colleague here, and he will talk a little bit of how we actually...
Yeah. So my conclusion is not about the platform, but is about planning the processes and everything.
Yes. Yeah.
So it's not about the mainframe, but the processes. So the thing is that I would like to mention ZS Connect as a product who is actually, well, I cannot say that because I think that mainframe is open to external world, but ZS Connect is doing a little bit more on the top of that. How to build API layer on the top of the mainframe? First of all, we need to, as Miro said, we need to analyze the process and what we should expose to the outside world and what should stay inside of the mainframe. Well, again, I cannot say that it is part of modernization. It is part of supporting business processes, but as a matter of fact, we got some products and we got some features on DB2, on Kix and other software on the mainframe, which are exposing either the code to outside world or the data from DB2 or from IMSDB, and somehow we can organize APIs, and we can measure those APIs and get some really interesting information about that. This is the picture of the mainframe and the picture of the cloud and everything what we do have in the IT ecosystem today. But I can say that everything is already connected between each other. So I don't think that we can talk about the mainframe that it is a silo inside of the IT architecture. It is not. A long time ago. just let's see what kind of opportunities do we have to interconnect those worlds. Yeah, we have some kicks, IMS, DB2, and other artifacts or objects which we want to expose to outside world. We can do that either through CTG, as Miro said, or we have IMS mobile feature pack, DB2 JSON, broker, service-oriented architecture was before 10,
15 years.
15 years, yeah. At least. Yeah, but it was very interesting, you know. Let's have one hub for everything. Yeah. Now today it is not anymore.
Everything is late in Croatia.
Interesting so much, yeah, but it can be used. So we actually have ZOS Connect as a gate to APIs when we are not talking about ACID and transactions. So if we want to have distributed transactions and if we want to have global transactions, it is, for me, it is smarter to keep that on mainframe. And if we want to divide some part of your business applications to expose to outside world and not to break the ACID, we have processes for that, and we have ZOS Connect in that purpose. Of course, on the distributed side, we have API management, which will help us to better understand the world of APIs and how they are used and how much they are used, and to get some measurements. Of course, we can bring a new security on the top of that. So, here we have a picture of mainframe cloud exposure. We have two pictures. One is for AWS cloud computing services exposure to mainframe, and another one is for Azure. We will see that. So on mainframe today, we are not running just, I don't know, PL1 applications or COBOL applications in the KICS or the IMS, but we have a bunch of all other kinds of applications, C++, Node.js, Python applications, and somehow we need to connect those two worlds. We are using different kind of protocols and of APIs, so we can do the REST, we can do the MQ, JDBC, SOAP, or HTTP. For REST, for RESTful connection between mainframe and outside world, we will use ZOS Connect, and that is why ZOS Connect is here on this picture. So practically, we can make one IT ecosystem from those two. Okay, the same picture, but with the Azure cloud platform, where we can actually keep legacy, let's say legacy workload on the mainframe, and we can build a new workload on the cloud platform and connect those two without any problems. Okay, regarding ZOS Connect, I can say that in the past 6 months, it's actually, or one year, it's actually with a new version we got a tool which is capable to be, how to say that, to be connected with the CI/CD DevOps pipeline, so we can actually do create the projects and the properties files, and we can deploy those to development servers, to the test environment, and at the end on the production servers and the pre-production environments. And we can use the same tool landscape, as you can see here, as for any other applications. So it is practically just one software for doing applications. So we can use Jenkins, we can build things, we can store the artifacts, and at the end we can deploy the projects for connecting to outside world. And this is something, well, pretty new, which means that we can build the API images, actually the containers, on the ZOS platform with the ZOS Connect. So we are not, we can actually containerize the ZOS Connect as a product either on ZCX or even OpenShift on the mainframe. Yeah. And for me, well, very cool thing now is so far we had legacy application and we have outside world. And how to connect those two? We need to build some APIs. Okay, with the ZOS Connect we were able to build those APIs on already existing legacy application, but we need to somehow to see what we can expose from the legacy application. And now we have top-down approach where we can first create APIs, and from those APIs we can get COBOL copybooks created with the ZOS Connect. So we can build brand new applications on the legacy side, on the, for example, KICS or IMS world. So I can say that mainframe is not an island in the enterprise world, but it is component as any other platform, as Paul already said. So that is all what I would like to say to you. So
thank you, guys.
Thank you.